present a little bit to you what StumbleUpon does, what are the problems that we are trying to solve. I don't know how many of you are familiar with StumbleUpon or have used StumbleUpon, but StumbleUpon is a quite old startup in the sense that was founded 11 years ago for solving a problem that no one was solving. And this problem was serendipity search. After 11 years, no one is still solving the problem of serendipity search. Not the big players are doing, not Google, not Bing, not Yahoo. Why? Because it's an extremely difficult problem. What serendipity search is about is basically the user come to stumble upon without a clear information need. It's not that you come and you say, I want to find the address of Trulia in San Francisco. You, and working for many years at Yahoo, it is clear, in the most of the case, what the user wants, and it's clear how to set up relevance measurements. And it's clear how to say, okay, the user was successful, the user was not successful in fulfill his information need. With serendipity search, this does not happen. The user arrives and want to find the information, but in a fashion that is more similar to be entertained. So we still need to present the user with information that is relevant to the user, but we don't have any clue about what is really relevant to the user. We have broad interest categories, but within an interest, you can really browse such a number of different facets and different aspects. The other big problem of discovery of serendipity search is that we present one result at a time. So, or is it good, the user likes, or is not good. There is no other, other way to do. In search, the effect is not so direct. The user has at least 10 results he can choose from. And so even if the result is not the first result, but is the third result, he still can be happy. He still can find what he was looking for. Serendipity search never repeats. You never see, well, there are bugs, but in theory, you never see the same page twice. And so this means that we needed to carefully select pages and do a deduct detection in order not to show you pages that are very, very similar. And if you think about news, in which usually you have a news that is repeated from many different websites, this is extremely difficult. The other important part of serendipity search is that needs to adapt. If you thumb up a result, a page, I need to be sure that next time that you search in that particular interest, I'm not showing you similar result that you can consider not relevant to your experience. Search, this doesn't happen. And the proof of this, we know we have the static result search, and in the most of the case, people is using search. I think that was around 10–15% of the queries are used as a bookmarking tool. So they don't save the address of Trulia anywhere, they just search again. And this is kind of bookmarking. And obviously, discovery needs, serendipity search in this case needs to be personal, needs to be very tailored to you. So we needed to provide different results if you are young, if you are old, if you are female, male, And some results that are good for people basically located in San Francisco maybe are not so good for people that is located on the East Coast, and so far so on. As I told you, I don't think that currently there is any big player, when I speak about big player, Google, but you can correct me, or Bing or Yahoo, that have tried successfully to solve serendipity search problem. How StumbleUpon works? Here, you come on the site, you register with email and password, or with your Facebook account. Second important step, you need to select interest. And this is a daunting step because we have 523 interests. That's it. You start stumbling, one at a time. Just you hit the button continuously. And what we hope that to basically take a big portion of the time that users spend on internet for, I will say, not work-related time. And it's very difficult. When StumbleUpon started, Facebook, Twitter, Pinterest, Reddit, what this guy? Now we are competing with the time that you spend looking at the picture of your friends, or tweeting about your personal life, or commenting about news, work in other similar networks. So it became difficult every day more and more. But still, we have users that are with StumbleUpon since day one. They keep stumbling. They are loyal. They come almost every day, and they keep enjoying the product. How we do what we do? Well, this is a really broad overview, but we inject content. We have two ways to do it. One is by user discovery. If you have a favorite page, you can submit it. Or crawling a subset of trusted source. Obviously, this changes over time, but we have a number of filters. Some the goal is to select good content. Other are just business rules, or try to understand if we have adult content, and so on. There is a second phase that is what we call sampling. And the sampling phase just try to solve the same problem that all the recommendation system have, and is the cold start problem. When I do not have any information about a page and I need to understand how good is it, we keep in this limbo for a minimum number of stumble or a fixed period of time, and we basically monitor how this page behaves. If this page passes the threshold of minimum quality, it becomes one of the page of our index, and we start recommending according to our recommendation methodologies. So obviously at the center of everything is the user, and the user tells us explicitly what he likes, so the set of his interest, and sometimes we see that he has a kind of favorite kind of news or trending content versus, evergreen content, for example. You can also choose some particular, keyword, and this becomes kind of channels. We actually have channel, but we are going to discontinue them. But we can see that there are some source that the user, some channel that the user prefer, but also we suggest results on the basis of what friends do. We have a similar mechanism of following, like Twitter. You can follow or be followed by friends. And obviously, suggesting what friends like is one of the most common thing to do. And at the end, we have also other implicit signal that we leverage and that are like-minded user, so users that have similar interest profile, so the same selection of interest or similar age, similar gender, and also expert. We have a methodology, algorithm if you want, that allow to select a top user within each interest. And so we know that this user usually submit to discover content that is high quality, and we leverage this user for suggestion purposes. What is the business model? Obviously, sponsored stumbles. Why this model is successful? And it's a quite successful model, I have to say. I think that, so the business model is called native advertising. What is native advertising and why is different from other form of advertising? All the other form of advertising, if you think about a TV or display, basically interrupt the user experience. What I mean with this, suppose that you're watching a movie and you are stopped to see a particular ads. This is breaking your user experience of watching a movie. Display advertising is the same. You are reading news, maybe politics, and you have a display of a car. It doesn't fit with what you are reading in most of the cases, and so you have to you need a switch from what you're doing to watch and click on the ads. This does not usually happen, I say usually, obviously, on native advertised. So the way it's done is an ad should be just another stumble. So in the ideal case, users should not realize that is not part of the user experience for the only difference that we have that sponsored mark on top of the page. And there are advertised ads that are pretty good on that. And in such a measure that users like them, thumb ups, they share ads. And for the advertiser, this is particularly successful because in the moment that user likes or share this kind of piece of content, this becomes organic. What I mean with this is that this is injected in our index and is served as the rest of organic content. So advertiser can actually reach a number of users for which they do not pay. Obviously, it's not always easy to give the user an experience that is organic, especially because we have two different types of campaign. One is managed, and for the managed campaign we can, and one is unmanaged. So user can actually submit whatever they want. But we reserve the right to show this content or not. So also ad is in the limbo for a while. If we start collecting a lot of negative feedback, we can actually decide to stop showing the ad. Because what we care the most is still the user experience. As you can see here, for example, the way it's done, they target segment, demographic segment in the most of the case. This is was showed to me because I am a woman in a particular segment in San Francisco probably. But as you can see, what appear here is kind of an article, mistake that you do when you take care of your skin. So it seems more health than not selling you product. But of course, they want to sell me some products. As I told you, this is an old startup. And this is a startup in the sense of 85 employees. But we have a user base of 35 million registered users, 100,000 advertisers, and a size of the index that is 100 million page. And as a matter of fact, StumbleUpon is the 4th social media traffic generator. We actually generate more traffic than not LinkedIn, than not Google+. So our Stumble are on mobile platform, and so this is another challenge. And again, number of employees 85. If we consider the revenue per employee is higher than not in Google, and this is something to be proud of. What is the data science role in this? Obviously, we talk about 85 total employees into office, New York, San Francisco. Engineering is in total, I think, 35. And data science is, I would say, me. No, it's 3 person plus a analytic engineer that is in charge of the data pipeline. 3 person that needs to take care or to support data-driven buzzword, innovation initiative, horizontally for all Stumble product. And when I say Stumble product, I mean mail, mobile, site, personalization, and revenue. And we actually are able to do it with, I would say, good result. So I'm going to present now a number of projects we have done. I'm not entering in the technical details, but if you have questions, of course, you can ask. I thought that for a talk at 7 p.m., you really don't want to be bothered, but you can contact me. And so the first 2 use cases are an example of how interest can be exploited and why they are so important. And a third example is some optimization that we have done for the revenue team. And I will briefly speak about what else we are trying to do at StumbleUpon. So as I told you, interests are very important. Very important, for example, for an infographic point of view. We can actually see and understand how users are using our product just to look at what they rate, correct? So we see, for example, that teenagers prefer nature-related topic, animals, pet, exotic animal, but surprisingly, they, for example, top rates, also interests like mathematics or writings. So really, teenagers likes mathematics? I don't think so. I think that they are using, especially when you have big number, right? They are using the site to bookmark resources, probably for homework. And so this is kind of different than saying they are using StumbleUpon just for being entertained. Being entertained is still the most important aspect of StumbleUpon, but looking at interest, we understand differences. If we look at women, for example, young women, for sure, they rate, I don't know, parenting, babies, kids, more than men, and this is not surprising, but still, they also, for example, rate computer programming-related stuff. And I don't think that this is, again, for entertainment. They probably bookmarking some resources for that they find useful for work. So the problem of gender prediction. Reading some, literature recently, I found this recent paper, 2013, that actually analyzed how the way people disclosure personal information on the web has changed since 2005. And actually, they noticed that there is a shift. People is more concerned now than not in 2005 about disclosure of personal information. This actually is from Facebook. They monitor how change the quantity of information that people is given about high school, hometown, birthday, interests, so far, so on. And so the blue is less dense. The red is a lot of more information. And this is the heat map, how it goes in the last few years. Another paper that I read recently was 2010. Actually, give some numbers. They say that 30% of users do not disclose their age on Facebook, 20% their gender, and 95% political affiliation. StumbleUpon is not different from the rest of the world, but our numbers are a little bit less. We have that 10% of StumbleUpon users do not declare their gender at the registration time. And age is mandatory because you need to be 13, I think, year old to create an account at StumbleUpon because there is adult content, and so we. But 0.3% of our users has more than 100 years, and 0.4% is in the 80-100 interval. We are still speaking about 100,000 of users. What you can obviously infer is that you should not trust age in general. So I don't know why you should trust gender either, but let's say that we trust the gender. Obviously, this is a problem, right? We do not have so many ingredients for a recommendation. We have demographic plus interest. If we cannot trust demographic, we are left just with interest. It's not enough. And also because targeting. Advertiser basically come to StumbleUpon and say, I want to target women that are in the segment 34-46 and that live in San Francisco. If we don't know the gender and we don't know the age, it's kind of difficult to do the appropriate behavioral targeting for ads. So we needed to understand who are these 10% of the user to increase retention, to increase revenue. And surprisingly, I found a lot of literature-related work, even recent related work that trying to solve the problem of gender prediction. There are some methods that just use link-based information, for example, in Facebook, and they infer gender just from the social network. There are some work that try to infer gender looking at textual feature. So if you write a tweet or if you write a comment for a movie, a review for a movie, I can do some processing on the language that you are using, and I can tell if you are a man or if you are a woman. Recent paper, this is from guys from Technicolor. They present this user gender based on ratings. So And this was Rexis 2012. And they actually say, just observing the ratings on movies, that is extremely sparse. We know that it's extremely sparse. We can say if you are a woman or a man with a good result. 86 on Flixster, 84% using logistic regression and 86 using SVM. Pretty good result. We said, okay, let's try. We have interest. Our model is extremely simple. What we did, we just look at the basket of interest. 1 if you user select the interest, 0 otherwise. Straight random forest. We basically train this model every night on 0.1% of our users. And initially we test on the Phoebe connected user for which we did not have any information. LC is 88. Way higher than what is not reported in literature for the same problem, just using interest. I'll see when we speak about machine learning and data mining, let's go back to the company and let's try to explain to the exec why this model is good. And this model is good because of this. If we can actually target 10% of the user that we cannot target before, the estimation of increasing in revenue is 10%, just with a simple recommendation classification model. So, interests are really powerful. We use for recommendation purpose. We use for understanding user. So we need to give the possibility to the user to really select the best interest for them, right? And this is not always easy. So I'm not saying anything new when I state that content that works on the web usually does not work on a mobile device. And instead, there are pages that are highly optimized for mobile, for the mobile experience. What about interest selection on a mobile? We have 523 interests. So suppose that you are creating an account on mobile, and users do. They actually create account using apps. Try to browse 523 interests with your mobile. Obviously, big bias. We have a lot of interest with A. But are these usually the interests that better characterize that particular user? So we said, okay, we saw that interests are powerful. So given the interest, we can understand user. What if, given the user, we try to present them with the best interest for them? But what we know in the moment that the user is creating an account, we know the gender, hopefully, if he said to us, the age, the device, the email, and that's it. And what we want to try, what is the metric that I want to try to optimize at this phase of recommendation? I want to optimize what we call activation. Activation is what tells us if the user that created an account is becoming a real user, a user that will come back in 7 days, in 14 days, in 30 days, so far and so on, possibly loyal user. We have good models to predict if a user is activated. There is a paper presented at WWW 2013, if you are interested in seeing our activation metrics. And so we basically can say, given a user and given this information, we can create a data set in which you say this user is going to be activated, is not. Big problem. we don't save interest, we don't have in our data the interest that user basically saved at registration. We have in our data set only the interest at the current moment. So, and obviously, as part of the recommendation, we present the user with, you liked mathematics. Do you want to browse also physics? So we really don't know what are the interests at the registration moment. But we can consider the interest in the very first session for the user and try to use that to understand which are the interests that better behave on mobile. We sampled the first session over a period of 3 months, so first session for each new user. And we try to see if we can apply any classification framework, if we can train any model. We tried a lot of, out-of-the-box methodology. None of them work. Coin is the best. So what we did was something a little bit different. We cast the problem as an association role problem. I think most of you are familiar. It's quite used. So we said, OK, let's extract all the rules that say interest humor activated equal 1, interest chaos theory activated equal 0, and so far so on. We fixed the minimum support to 15%, the minimum confidence to 70%, and the minimum lift 1.1%. In this way, we always pruned all the rules with the same left side, not indicative, right? And as a result of this first two steps, we were left with 80 interests that are actually 15% of the total interest that we have. So one natural question will be, but maybe this is because users actually select only these 80 interests on mobile. So we did a comparison, and we actually see that the cumulative distribution of interest Stumble on mobile and on web toolbar, the website, the number website, is mostly the same. So there is not such a bias that only 80 interests are actually used on mobile. We did a second step, and we said, OK, at this point, we will use the demographic information. And we just ranked these interests on the base of popularity. So thumb up, thumb down. And so obviously, the results are interesting. And we, at such a extent that we are going to A/B test this, we could not because our mobile system was not prepared to dynamically select interests. So the interface was static. So we could not change the order. So we had to wait for front end to do the necessary modification. So this is a comparison on the segment on two different devices. One is Android tablet, the other is iPad, for men and women under 24-year-old. Can you tell who is a man, which column is a man on Android? I could, without looking, without knowing. And this is because I really think that there are some, things that we say about gender diversity or user on Android versus user on iPad that actually are true, as a matter of fact. For sure, you can say who are the women here, the two columns that are the women and the two columns that are men. I mean, it's so evident. These are less than food cooking. No way that a college male student is going to browse cooking recipe. And they are. Drawing and drawing, only women. Who is the Android guy here? The Android man? Come on. Hacking. It is the Android. So it is actually interesting. What is the thing that I noticed here? I told you that in the top rating interest on the web, I found that in general teenager also rates mathematics, also rates physics or something that they're writing. None of this interest is here. Because obviously you are not going to do your homework on a platform like this. So if you are a user that is signing with a mobile device, your purpose is mostly entertained. So this is a totally different experience. It's a totally different way of using StumbleUpon than not on mobile. Similarly, this is the top comparison for over 46-year-old. Now food cooking is over, so everyone eats after 46-year-old and they want to eat well. But you will see that women, for example, there is health. Health is something that everything care. There is no more music anymore. That was instead, music was in the other slides. But men are worried about health. What is it? Health. Instead, women are worried and want to browse alternative health. They really don't have any health problem. They just want to be alternative. And iPhone, iPad, actually, they want to travel. Android guys seems that they don't. They don't want. So there are differences that actually the device itself, Android versus iPad, put in evidence. And when you think about, are not so hard, right? So this is the last thing that I want to talk kind of in semi-details. And after I have just an overview of other problems we are trying to solve. This is very fast. So as I told you, we have two different ways to do advertising, two different type of campaigns. One is the managed, and the other is the unmanaged. Static price. We don't have a bid. We don't have any dynamic pricing. It works so well that we don't need any form of optimization so far. So, but we have a payment threshold. So especially for the managed campaign, if the user does not stay at least 4 seconds, we are not going to get any money. And this seems like kind of opportunity. I mean, if we have campaign that in any case we get money, and campaign for which we don't get money if the user doesn't stay for at least 4 seconds, maybe we should try to optimize. And what we did was a very simple, statistical analysis. So what we did was we simply computed the probability, the tendency of the user to skip. What we notice is that there are users that naturally skip. They actually, especially on mobile, they skip. They read just the title. And this is the way they actually use, not even if it's good or bad, they actually use the device like this. Why we want to send advertise to them? Or if we want to send advertise to them, the one that does not have a threshold for payment. And the other thing that we did, we computed the expected amount of money to be made by serving a particular ads with a particular threshold to the pair user device. And we rank. This basically is happen every night. And we have this optimal selection of ads to user on the basis of their tendency to skip. As I told you, obviously, this model works when we have a lot of ads, especially, for example, in months like December, which we have the peak of advertiser, and all of them want to serve a lot of ads, in which the skip rate improved by 7%. And this means in the top week of December, a net gain of $7,000 per day. Just this. Understanding the tendency of the user to skip. This is the last, I will say the last that I want to talk. We are doing other cool stuff. We're doing a lot. For being a tree, I think that we are really have a throughput that is amazing. And I have to say, I worked at Yahoo for 5 years. And the constant problem that as a data scientist, that there was not data scientist at that moment. We were applied scientists. At some point I became data scientist. But the big problem was the limitation. We never were so fast as engineering. Engineering was ready to deploy next model, and we still needed time. This is the first time that I actually do not have this problem. Our throughput is higher than not engineering. So we actually have the ability to say, are you deploying this? I'm not going to give you any support. You have other two model, other two algorithms to deploy. But we're doing some cool work. The first work, we are actually trying to use dual time to predict ratings. We are doing something very similar to this paper, Wisdom 2014. So we actually still are segmenting our items on the base of interest and user behavior. And we are basically using a probabilistic model to understand how TOS distributed with respect to rates. Current baseline with random forest has an accuracy of 75.7, but this is our baseline. This is an extremely important project. It's going to help a lot with the cold start problem. So as I told you, we have a limbo state in which pages are for 24 hours or a minimum number of stumble. But if we don't reach enough rating in that limbo period, the page is discarded. But what if, since we didn't know anything about the page, we just presented to the wrong user? So the idea is that we do not have time to collect enough evidence, even if the page maybe is good. This will help a lot. And also to recommend. So again, recommendation, this is a recommendation engine. I like, I don't like. But also all the recommendation engines have the exactly same problem. Ratings are sparse. A model that actually exploits dual time is not a sparse model anymore. It's a model for which you have one vote for each item in your index. The other project that we are doing is in collaboration with Professor Serran and Professor Dong from the University of Santa Clara. And this is we want to predict the user churn. I mean, this is a web app, a web product. User get bored and they leave. So we needed to counteract. So predicting user churn is the most natural thing to do. We are using this model from this paper, Counting Your Customer One by One. And this model is basically is a consumer behavioral model. And is based on hypothesis of Poisson purchases and exponential lifetime. We have a baseline, pretty strong. We are adding covariate. Covariate means demographic or other information about the user. The idea is that we will have kind of rates for each user that is telling us this user is going to stay loyal, this user is going to leave soon. And obviously this will be used for notification purpose. So if I have to select a number of users that I want to send an email saying, look, we have extremely good content for you. And also we haven't done, I would say, till this moment, no work on our social network. So we have not exploited leaders. We have not suggested friends. So we are starting work also on this. And this is not all, but I would say this covers a huge part of what data science means at StumbleUpon. And thank you.